Hi everyone, welcome back. This is Raju from Smart AI Technologies. Today we will be showing you a project called Deepfake Detection using deep learning. So this is the website that we built. So you can see here the accuracy and loss graphs as well as some implementation samples of the video frames, fake and real. So this is a front end built using HTML, CSS and JavaScript. In the back end we used Flash framework for the integration. And this web app is built after training our deepfake model detection model using deep learning. So in this video we'll be going through everything. The first part will be studying about the deepfake, what is it and what are the problems caused by the deepfake and how to solve it. All those things we'll discuss one by one. Then we'll go for the existing system, what the base already present research papers are using. Maybe you can see paper 1, paper 2 and paper 3. What are all the existing system they are defining and what are the results they are getting. After that we are going to define our own proposed methodology to solve the problem and to get the better result than the existing paper. Then after the completion of the discussion of the existing paper and the proposed system, we will be seeing the demo of the project, the complete demo of this project, how to upload a video, how to get prediction done and how we are going to get the result displayed and everything. So that till that we discuss everything, like from part 1 to part 4, from discussion of the introduction to the implementation as a web application one by one. So before moving further, we are Smart AI Technologies who provide service as a project maybe for BE, BTech, MTech and as well as PhD students in AI, ML and data science domain. So if you are new to our channel, you can visit our channel and you can see, so there are so many projects already deployed which are on ML, AI and data science, as well as there are so many videos which are completely free. Especially there is a Excel related courses there for data analysis. Data analysis using Excel is a free course that you can avail if you visit our channel. And again, there are so many videos which are for free, around more than 80 videos which are almost for free with the data already given. And there are so many projects which we charge. Okay, now first of all, what is the deep fake stuff? What are deep fakes? They are nothing but the fabricated media, nothing but they are manipulated, maybe videos, maybe audios, maybe images. If some real image is there, if you manipulate in such a manner, no one can differentiate it to some other form. So that what called is deep faking. Deep fake is nothing but deep learning plus fake. It means fake something with help of deep learning. That is called as a deep fake. So especially here, what technology is being used is GAN, generative adversarial networks. So they are having two things. One is generator, another one is discriminator. With help of this, always these models will be getting upper hand. It means they will always be in an improvement mode. So one will generate something, another one will check how the thing is generated. So why and how deepfakes are very dangerous nowadays? The first thing is misinformation and disinformation. So within this, if you see, it is all because of the false information that is being provided. Okay, maybe it will be like saying or giving some news or providing some audio of some person deep faked where he didn't spoke anything. Maybe it will happen mostly in case of politicians, and which is always linked to the public. So all these things will interlink to the election and social issues. Here mainly the audio deepfaking will be causing the problem here. The next thing is identity theft and the fraud detection. So here mainly face swipe is one of the stuff. It means if there is an when it comes to identity theft and fraud detection, mainly it happens with the video where face of someone will be replaced with some other person or AI generated faces. So this is the biggest problem. You may heard about so many cases nowadays. especially Rashmika Mandana's case, that caused a lot of issue. And then we got so many videos maybe related to Narendra Modi as well as Mamata Banerjee, which took entire news. So these things, especially video, face raping and some other stuff, they will cause a lot of issue even when it comes to the famous people like CEOs or politicians. And then comes cyberbullying. Mainly it will happen only in the case of video making. They'll cover a video of some person, their private videos, then they will change the face of that person, or some random videos, and then they will change the face of that video. Okay, these things will be affecting the personality of that person who didn't involve actually in that video, some random video, but the face of them will be changed to some other. Mainly it will almost be the personal videos. Then comes security and national threats. It will be directly related to military and political leaders. Normally these things will be directly impacting on the national related issues. Erosion of trust. So because of all the above stuff, people will lose the trust in the technologies. And till now we discussed why and how deepfakes are very dangerous and they are causing so many issues. Now we'll see the positive side of it, how deepfakes can help us. So when we are speaking about the profit and the positiveness of the deepfake, the first thing that we'll get is entertainment and film industry. So here, in absence of someone, maybe or some actor, we can take help of some other stuntman, especially in stunt cases or action related films. Normally actors can't do all the stunts, so stuntmans can do it. So in that case, using AI to change the face of the stuntman to the actor will be giving you a realistic effect. So all those things will be very much helpful, as well as voice overing. Like these technologies will improve the way that we see the films, visualize the films. Then comes education and training. So here there are so many scenarios here how we can use deepfake. One thing is to picturize the scenario. For example, we don't know how was the Napoleon, so, for example. So you can generate and you can visualize based on the characters, the character is being explained historically. You can generate a figure and you can understand. Like that you can generate any historical figures or scenarios to understand the things better. As well as it can also be used to visualize some scientific scenarios. Restoring lost voices. Again, as I mentioned, if there is a film actors, okay, and whom we lost, so we don't have their presence to get a voice. So in that case, you can use this technology to greet in their voices, to use their voices for the next film or something like that. Then comes our artistic and creative expressions. So here, when you generate using AI, the expression can be manipulated in any way, in a good looking way. So after that, the actors can follow that. A person can follow that so that he can make the things visually better. Now third one is how to solve what is already there, how to solve the dangerous scenarios created with this deepfake, how to overcome this deepfake negativeness. So we are defining how to overcome in our paper is using CNNs and RNNs. So these are all deep learning models. So deepfake is nothing but they are GAN, they are also using deepfake, using deep learning. Now the problem that is created by deep learning should be solved by the deep learning itself. That's why if GAN creates deepfakes, let us CNN RN detect what is the deepfake. So then comes watermarking and blockchain verification. Using blockchain, we need to authenticate the real ones so that it will differentiate from the deepfake created things. Same thing will happen with the biometric. With the biometric authentication, there will be authentication over the data. So the deep fake created data can be easily separated. And public awareness. It is the duty to make public to understand AI technology is not only a dangerous one, how useful it is, okay, and how to overcome the problem caused by the deepfake or any AI technology that is being used for the uh, wrong way or the wrong implementation of the AI. Then comes the concept called multi-modal deepfake detections. The deepfake can happen in any format, maybe it is audio, video, text. So in all of them, we need to be able to detect it using multiple technologies. One of them is lip syncing. Maybe if there is a deepfake generated video with audio, you can lip sync and understand whether it was fake or real. And some open source AI initiatives by any research and some of the research or any countries from their government side, they can do it. It means providing the free data for the researchers, providing support, money support, price support, so that there will be a lot of research over this deepfake detection and resolving, so we can come up with the better idea and the best results. So till now, whatever we discussed, it was all about the deepfake. What is deepfake? What are the dangerous stuff that is being done using deepfakes? And what is the positive side of deepfake? Then comes how to solve the deepfake issue using the technologies. Now, as I mentioned, we are going to see few IEEE papers as a existing papers as a references and as a base paper. So each paper we are going to study and we are going to extract the information from these papers and we are presenting them. The first paper that we are going to take is deepfake detection through deep learning. So this is that paper. So when you go through this paper, here some images are being provided, deepfake video of Barack Obama as well as deepfake video of Nicolas Cage. Like this, there are so many deepfake videos are being generated. This paper introduces with these two images, and when you go through the methodology, what are all the things that you are going to get? Maybe what data set they used, what are the machine learning or deep learning model they are using, how they pre-process the image. So all those things we will collect, okay, and we have pasted it here. Okay, in this paper, what are all the things are available is input conversion. It means initially that paper is having a data set that contains videos, but first those videos are being converted into images or frames, what you say. Now under pre-processing, they will crop only face area. It means the mainly deep face detection is done here, and frame extraction. But from each video we are going to extract each and every frame. Then with help of OpenCV, especially R cascade frontal face, okay, mapping mapping file, only the face part will be extracted from each frame, and the images are being saved in 2 pixels. One is 299 into 299 and another one is 224 into 224. 299 cross 299 they done for exception model, 224 cross 224 they done for MobileNet. And what are the different models they are going with? One is exception model and another one is MobileNet model. They are using two models. And for training, because the data set will be very huge, and what they are using for the training, they are using the resources provided by University of Melbourne. Okay, So this is a cluster they are using, and they are going with TensorFlow and CUDA, what they are mentioning. Now when it comes to dataset splitting, they are considering 80-20 ratio. And training configurations, these are also much needed informations, are what we call as hyperparameters. So optimizers, they are going with Adam optimizer, batch 32, epochs 10, and labeling, it is yes or no, that is 1 or 0. So the next paper is deepfake video detection using deep learning neural networks. This paper. So in this paper, in their methodology, what they are presenting, especially this paper speaks about multiple models, especially one of them is ResNet 50 for deepfake detection. And here in this paper is not much providing any information about in depth about pre-processing and all those things. Mainly they are concentrating on ResNet 50 first. Initially they mentioning ResNet 50 they are going with, and dataset collection, they collected dataset fake videos. Again they even gone with the same dataset and extract video frames and normalize the pixel value. That means initially the image will be having 255 0 to 255 for a pixel RGB each one, so they will be normalized so that each and every pixel will be divided by 255. Now they are going with ResNet 50 as a model to extract the feature from the given image. And for classification, they are going with classifier. They are actually using a machine learning model for this. Metric, okay, finally they are getting these matrices: accuracy, precision, and recall. Now when you see these two papers, there are so many gaps, okay, research gaps, so that we need to address first. So then we need to propose our own model. Once we go through all the three research papers, we will be proposing our own model which is better than the existing model. So they are using pooling layers in between, and okay, they are going with LSTM model. So this will be like ResNet 50 plus LSTM combination they are going with. So LSTM layers, these things are providing us the little bit detail about the LSTM model. So what optimizer they are using, okay, and what loss function they are using, and what is the output layer. In our case it will be binary, so there are two classes. Output layer will almost be having two classes in the end. So even they are going with hybrid architecture, that is not, but as I mentioned, it is ResNet 50 plus LSTM from this paper. Then comes the last paper, that is deepfake detection using deep learning technique, a literature review. Whenever you open any research paper, it says literature review, it means this paper they are trying to read some existing previous papers, then they are providing the information. That's all. They themselves will not be coding normally. So you can say it is a literature survey. It's a completely literature review. It means read some existing paper and present it. So this paper presents about so many previous papers with the details like this. This is one of the paper, and this paper is using CNNs with some particular layers like ReLU, and then what are different type of models are existing there. Okay, normally you can go with the CNNs, then you can go with the RNNs, then you can go with LSTMs. This is one case, and then comes image detection model, image detection methods of this paper, what they are attaching. So what this paper is trying to present is they are going with Gaussian blur in the pre-processing method. This is little bit extra they are presenting. Till now whatever the paper we used, they are almost discussing mostly about models. Pre-processing stuff details are not being discussed in the previous two paper because they were presenting, but here This paper especially discuss about the Gaussian blur. Then comes video detection methods. Again, it is LSTM plus RNN, hybrid LRCNN. And what are the different deepfake datasets are available for us? So DFFD, that contains around 1 lakh to 2 lakh fake images generated with ProGAN and StyleGAN. VGGFace 2 with a 3 million facial images of 9,000 individual showcasing. Okay, with a different age, race, and lighting conditions. Flickr Faces HQ, which contains around 70,000 high resolution images of human faces created by GAN. And there is another dataset called as 100K faces. After this, we used evolution matrix at the end. So among them, accuracy, area under curve, precision, receiver operating characters, ROC curve, as well as F1 score. These parameters are being used to evaluate the models. So these are the informations provided by the existing system. Now comes what we are going to propose. What special that we are going to do than the existing papers. In our case, we concentrate more on image pre-processing. So whenever we get facial images of facial image dataset that we are having, first task we are going to do is we will apply multiple filters. For example, Gaussian noise removing filter. Then we will try to go for histogram. Then we will try to change some intensities, that what we call as augmentation, by changing the intensity. So we apply augmentation. In that augmentation, mainly we try to concentrate on intensity change. So we are going to make the data set having more variations. So when we use augmentation, the profit of augmentation is that it will try to increase the dataset size, as well as it will insert some variation in the existing dataset. So whenever you train any model, we will almost try to solve the problem of overfitting or underfitting when you try to go with augmentation. So we are defining more filter methodologies, maybe Gaussian filter, maybe augmentation techniques, especially with little bit changes in the intensity and lighting. And then goes the feature extraction. So in our case, as we are moving with the deep learning, we are going to multiple deep learning techniques. Our concentration will be mainly on ResNet 50, EfficientNet, and then comes MobileNet and VGGFace. So these 4 models, we can plan for few other models also, and hybridized models also can be used. So in this paper speaks about only 2 models. We are going with multiple models than this, which normally proved a better result. So normally EfficientNet gave us the better result than what is existing. And training environment, we try to train on a GPU, and we train our model for 50 epochs, and those 50 epochs we have trained our different models. And when it comes to splitting of the data, we gone with 70-30, and generator and sample memory, whatever they are saying here. In our case, we are saying all those things in our local system. And when it comes to hyperparameter tuning, we have used for optimizer Adam batch size. It depends. So if we use low image size, we try to increase the batch size. If I go with higher image size, pixel size, then I will reduce the batch size. If I increase both of them, you can train if you have a strong GPU. But as we are having a limited GPU, we are trained with the 32 batch size itself. And in this paper case, it is being training 10 epochs or like that. In our case we are training for 50 epochs. So in our case also it will be fake or not, it means 1 or 0 label itself. So in our work we are concentrating mainly on the pre-processing stuff, and we are planning for something extra there. So we are trying to go for explainable AI concept also need to be integrated. We didn't integrate now, but we will integrate. If you approach us, we'll try to go with even the explainable AI stuff. Whenever we use explainable AI as a support, it will help us to go with a better ROI. For example, if on a face particular region is giving us the variation to predict whether it is fake or not, that we can do with help of explainable AI technology. So if we integrate that with this paper, we will be getting the better result than what we are already getting now. So this was all about our existing and proposed system. Now we will test our web application that we built. So this is a home page where some sample results are being shown here, and this is only one model we are attaching, that is EfficientNet. We could have even attached Resident 50 with the VGGFace results. So you can add all information here. Even I will be showing you notebook files which we trained. So first we'll test it with few videos. So this actually label file. So we'll see which is a real and fake video. Then according to that we'll feed and we'll validate it. So this video I'm uploading to the model. As I mentioned earlier, this web application is built using HTML and CSS in the backend, as well as HTML, CSS and JavaScript in the front end, as well as Flask in the backend. So they are being integrated. To that Flask app we integrate our trained model, whatever we train that model using EfficientNet or RustNet or something. The best model will be selected and that will be integrated in the backend. So whenever you upload any video, first that video will be taken, each frame will be taken, then we'll choose some 20 frames or like that. There we'll try to detect face. We can do it with multiple way. Either you can go with YOLO, either you can go with R cascade, or you can go with MRCNN. Any type of detection models you can use. The only face regions will be bounding box will be drawn over the faces. It means that is our region of interest. That region of interest, the only face will be taken back and that will be fed to the model. So now the prediction will be done in the backend for each frame, each face. That results will be running here. So once the frames are being predicted, the result will be getting here. These are all things happening in the back end. The processing of the frames are happening because each and every frame should be taken one by one of that video. That is the reason the model will take a little bit time. In some frames actually there will be multiple faces. That is also one more reason for the time. So now we got the results, you can see here. So this is the video uploaded, and as you can see in the label file, this is a fake video. You can play that video also if you want. So the video that we uploaded was this one. So actually there are two, one is real and another one is fake. So this is that video. You can see the variation on the face. So this is entirely fake video that is being predicted by our model. So you can see multiple times you yourself can identify this is a fake. So our model is doing that task. So now what we do is from here we'll upload real video one. Now we will be uploading the real label video. So it may take a little bit time to process all the frames. You can see here it started to process. It says real because each and every frame here will be processed. Each frame will be taken, the face will be detected. When the face part will be detected, that face part will be sent. The face part will be sent to the model that we trained. That model will give back whether it was fake or real. That will be updated here. Even you can download and see the images if you want these images. So mainly the face will be concentrated a lot. It says the face part is actually fake, so that is being taken, and there will be so many frames. Okay, the result will not be done on only one frame. Now you see in the backend it is happening. It is happening for each and every frame of that video. Now as you can see, this is a real video, so we are getting real frames. Finally it says this video is real, the frame is real. So you can see here, you can go here and search for that video which we uploaded and play it. So this is a real video, you can easily find it out. So our model is predicting lot better and perfect. Can upload some other images and videos. In our case we are giving directly video upload option. You can go with let me take few more videos. This video will test. As you can see, we got the result and all the frames are saying fake because we uploaded fake video or deep fake video. Till now we uploaded around 4 to 5 videos. You can upload any number of videos and you can test on it. So we have built a good model with good accuracy. Even I can show you notebook files. Only ResNet 50 and EfficientNet code I will be showing you now. Not complete codes, because for complete code and documentation you need to approach us. Here we'll be showing you a few highlights. Okay, what accuracy we got and all those stuff. And when it comes to EfficientNet, I try to implement using PyTorch. So we wanted to just know whether using PyTorch we will be getting better accuracy, whether by going with TensorFlow and Keras combination we will get a better result. That also being tested here. So here you can see this is of ResNet 50, and ResNet 50 for 50 epoch is giving us a good result. As well as you can see the recall score, reference score and precision scores, we are getting far better result than our expected result. And same thing when you come back to this one, which we try to train only for 10 epochs normally, and we are trying to improve this one, EfficientNet be not. So this EfficientNet model giving us almost good accuracy, precision 100% or like that, but there is a little bit differentiation with a recall for two classes. So this is being handled here. So as I mentioned initially, the augmentation stuff and pre-processing stuff, so by integrating them, we are overcoming the difference between the two classes, precision recall and F1 score. So that's why the difference is only 0.01 or 0.03, again 0.01. And whenever you see this result where we didn't do those things because we wanted the comparison, we do R&D. It is not a one-time code and state coding. Here we do the combination of stuff. Here we change models. Here we change the way that we implement. So until and unless we get the satisfactory results, and when you approach us, it is not like you need to take the same code. If you are having your own idea, if you are taking any paper as a base paper and there something is given, so if you want to implement that, we'll implement. So the final aim of the work is to get a better result than the existing paper. So always we need to concentrate on improving the existing system. So then only you can write some research paper based on your works. Else otherwise if you go directly Python coding and whatever you get, you put it there, and if you think that would be published as a paper, it will become little hard to publish a paper in that cases. And these things are being done, and you can see it is being tested on the face images. That's why whenever we upload on a video, that image, the whole video will be taken, each frame will be taken out. For each frame the face will be detected like this, and over that face the deepfake is done or not will be detected using our trained model. And we can implement so many other models. As I mentioned, we implemented even VGGFace and MobileNet like that. You can go with multiple models, and even DenseNet you can try with the DenseNet. So like this, if you come up with your own idea, your own changes, that also can be taken as an input for the improvement in the next case scenarios. Otherwise you can improve the data set size, something else, because there will always be a space for improvements than what is already existing. Yeah, this was all about today. And if you need complete code and documentation and support to solve this problem, and to get a better result than what is existing, as well as it is not like we are just giving the Python code and HTML code. We will be giving you all these research oriented whatever we are doing. And also if you are having your own idea for the research, you mention it and you ask us to prepare, we will prepare it and we will give it customized requirement what we say. And if you want to look into the Python coding and HTML coding, these things are the syntaxes. Okay, all these Python codes will be there. These things will be given to you, and we'll be helping you to implement everything in your system. And we'll be setting up a classes for complete explanation. We'll be mentoring you. For example, today you take this project from us, and tomorrow if you get any error, or if you want make an improvement after taking the entire project, in that case you can take our support, and we will be helping you to make those changes according to your interest. What are the possible changes can happen, those changes can also be done. So for the complete support and mentorship, you can contact us to the given number below, or you can visit our website also. Thank you very much, and in the next video we will be coming up with some better project. Yeah, thank you, goodbye.